Hello students, my name is Sanket and welcome back to my world of mathematics in Sanket Sir's Maths Academy. Let us continue with the topic of Basic Proportionality Theorem, and today we are going to look at the ratio of areas of two triangles. We know that area of triangle is equal to half into base into height. Here I have drawn two triangles, triangle ABC and triangle PQR. In triangle ABC, if I consider the base BC, what will be its corresponding height? The height will be the perpendicular drawn from the third vertex A on the side or base BC. So AM will be the perpendicular, that is the height, and BC will be the base. Therefore, I can say area of triangle ABC will be half into base into height, that is equal to half into base BC into height AM, right? So we have got area of triangle ABC. Similarly, for triangle PQR, if I consider the base QR, what will be the height? Height will be drawn from the third vertex P on the base QR. Now when I try to do that, when I try to draw a perpendicular, it is coming outside the side QR, the base QR. So I extend the base QR and draw the perpendicular PN. Thus QR will be the base and PN will be the height, and we can write area of triangle PQR. What will be the area of triangle PQR? It will be half into base QR into height PN. Now that we have the areas of triangle ABC and triangle PQR, what is our next step? We had to find the ratio. So let us take area of triangle ABC upon area of triangle PQR. We will be getting half into BC into AM. Let's write that down. Half into BC into AM upon area of triangle PQR, which was half into QR into PN, right? Half into QR into PN. Now if you observe, what can get cancelled from numerator and denominator? The fraction half, right? The rational number half can get cancelled. We will be left with area of ABC upon area of PQR. Let's write that down again. So I have area of triangle ABC upon area of triangle PQR. It won't be now half into base into height upon half into base into height. It will be simply base BC into height AM, that is BC into AM, upon the base into height for PQR, that is QR into PN. What do we realize from this? We realize that for any two random triangles ABC and PQR, the ratio of their areas is equal to the ratio, this is a fraction, which means it's a ratio of product. See, we have a product in numerator, product in denominator. So it is ratio of products of what? The products of BC and QR. What are they? They are the bases. So products of bases with what is AN and PN. So AM and PN are the corresponding heights. So we can say ratio of products of bases with their corresponding heights. We can write it as a generalized statement, and I say that if I have two triangles, let's say triangle 1 and I have another triangle, triangle 2, then the ratio of areas, so area of triangle 1 upon area of triangle 2, ratio of areas of two triangles will be equal to what? Ratio of the products of their bases and corresponding heights. So let me say B1 into H1 for triangle 1 and B2 into H2 for triangle 2, where B1 and B2 are the two bases, H1 and H2 are their corresponding heights. Now let us consider two triangles ABC and PQR such that in ABC the base is B1 and height is H, and in triangle PQR I consider the base as of length B2 and the height PN is of the same length as of the height of ABC, that is H. So what do we understand? For triangle ABC and PQR, the bases have different heights, say B1 and B2, but their heights have the equal lengths, that is, let's say H and H. Then what do we have from this formula, that is area of triangle 1 upon area of triangle 2? B1 into H1 upon B2 into H2. Still, if I just write for area of triangle ABC, it's going to be half into B1 into H, and for area of triangle PQR it's going to be half into B2 into H. Therefore, ratio of areas of two triangles, we know it is a B1 into H1, base of first triangle into height of first triangle, upon base of second triangle into height of second triangle. So for area of triangle ABC upon area of triangle PQR, we can write base into height upon base into height, that is B1 into H upon B2 into H. But we see that the heights are same or equal for the two triangles, so we can cancel the height from numerator and denominator, and then we will get area of triangle ABC upon area of triangle PQR as only B1 upon B2. Can we generalize any statement from this? Yes. So when triangles have equal heights, the ratio of their areas is equal to the ratio of their bases. What did I say? Triangles having equal heights have their ratios of areas equal to the ratios of their bases. I can write this as, if heights are equal, then the ratio of areas of two triangles is equal to the ratio of their bases. Let us consider different cases where we have triangles with equal heights. So the first case is where the triangles lie between the same two parallel lines. So suppose we have here line L and line M parallel to each other. So I will write line L parallel to line M. And then we have, if you observe, triangle ABC lies between the same two parallel lines. A is on one parallel line, base BC on the other parallel line, and triangle PQR also lies between the same two parallel lines L and M, where P is on the parallel line M, base QR is on the parallel line L. So I will write here triangle ABC and triangle PQR lie between the same two parallel lines, which are they? L and M. Then what do we have? Observe very carefully. For triangle ABC, considering BC as the base, I draw a height that is perpendicular from vertex A on BC. AM is the height. For triangle PQR, we see it is obtuse angled at the vertex Q. So for drawing the height, I have to draw from point P towards the base QR. PN will be the height. So AM is the perpendicular height for ABC, PN is the perpendicular height for PQR, but both AM and PN are basically the perpendicular distances between the two parallel lines L and M. But L and M, as I said, parallel, which means the distance between them is going to be constant. It's going to be constant always. So we can say that the height AM will be equal to the height PN. What do we understand then? That the two triangles ABC and PQR have equal heights. And we know that if the heights are equal, area of triangle upon area of triangle is equal to base upon base. So here we can write area of triangle ABC upon area of triangle PQR will be equal to the ratio of their bases, which in this case are BC upon QR. Right? So the first case where the heights are equal is when the triangles lie between the same two parallel lines. Let us try to understand the second case. So the second case where the triangles will have equal heights is something like this, where the triangles with bases on the same line. So that there are triangles whose base, the base side of the two triangles will lie on the same line and they will have a common vertex. Now if you observe the two triangles here, I have shaded them with different colors. So consider triangle ABC and the triangle ACD. We see that the bases BC and CD are lying on the same line. So you will have to write down that triangle ABC and triangle ACD have their bases. Which are the bases? BC and CD have their bases BC and CD on same line. You can mention the name of the line also. So the name of the line in our case, you can mention the extreme points, that is from B to D. So that is on the same line we can mention BD. And both of them, if I consider BC as the base, what is the opposite vertex? A. If I consider CD as the base, what is the opposite vertex? A. Can I say triangle ABC and triangle ACD have a common vertex? A. So I will say and they have common vertex A. So in this second case, what do we have? We have triangles having base BC and CD on the same line, and their third vertex is the common vertex. What then happens? If you observe for triangle ABC, which is obtuse angled at the vertex C, the height is going to be perpendicular drawn from opposite vertex A towards the side BC. AM is the perpendicular, is the height of ABC. AM is the height of ABC. And in the same manner for triangle ACD, to draw the height, to draw the perpendicular from opposite vertex A towards the side CD again, AM is the height for triangle ACD as well. So triangles ABC and triangle ACD have the same height. It's a common height for both the triangles, which is AM. Isn't it same as triangles having equal heights? Equal heights, same height, common height, one and the same thing. So ratio of areas equal to ratio of bases. So I will say area of triangle ABC upon area of triangle ACD will be ratio of their bases. What are the bases? BC and CD. That is BC upon CD. Let us consider triangles having equal bases. So, I am not drawing a diagram, but let us understand. For triangle ABC, suppose we say that the length of the base is B and the length of the height is H1. For another triangle, let's say PQR, the length of the base is same, it's B, but this time the height is another height, that is H2. So we see that the heights have different lengths, but the bases are equal. Then what can we say about the area of the ratio of areas of triangles? For the ratio of areas of triangles, it is base into height, that is B into H1 for ABC, upon base into height, that is B into H2 for PQR. What does get cancelled? We see that the bases are equal, so they will get cancelled from numerator and denominator. So now my area of triangle ABC upon area of triangle PQR will be simply height 1 upon height 2. We get our next rule, which says for triangles having equal base, the ratio of their areas is equal to the ratio of their heights, right? Let us understand this better with one small example. So let us consider an example as shown here. We have two triangles ABC and DBC. Let us write down the name of the two triangles. We have triangle ABC and another triangle DBC. Do you see what are their bases? Their bases are BC for ABC. For ABC also the base is BC, or we have written as length small b. And for DBC also the base is BC, we have written as the length as small b, which means their bases are equal. And what have we learned about triangle with equal base? The ratio of areas is equal to ratio of their heights. So ratio of area of ABC upon area of DBC will be ratio of their heights, which in this case are H1 and H2. So yes, here I can write area of triangle ABC upon area of triangle DBC will be the ratio of areas of two triangles with equal bases is equal to ratio of their heights. So that will be H1 upon H2, right? Understood clearly? So what have we learned in this particular video? We have learned three important things. We have learned that for any two triangles, the ratio of their areas is equal to ratio of products of their bases with their corresponding heights. How to find the corresponding height for a given base for a triangle? We have learned this in your earlier videos. Please refer to the video to understand the relation between different bases and their corresponding heights. So again, ratio of areas of two triangles is equal to ratio of products of the bases with their corresponding heights. If the heights are equal, then the ratio of the areas of two triangles will be simply equal to ratio of their bases. And if the bases are equal, then the ratio of areas of two triangles will be equal to ratio of their heights. These are three formulas. These concepts are very important in proving the basic proportionality theorem, also known as Thale's theorem. They also prove useful in solving several questions related to triangles.